the formative and summative on your own. For me, when I'm facilitating these classes, I prefer to go through the learner manual, and then the formative and summative, that becomes your problem, right? I don't want to teach from the formative or from the summative. All right, so the topic today is support a local area network, a computer network, right? Maintain the performance of a LAN. So last time we looked at a tool that we can use to automate or to make things easy for us, like like to monitor our network, also to install operating systems on many machines at the same time. And then also we looked at that tool. We can use the tool for reporting. So we did dive in and look at the Manage Engine tool. That tool, we call it the Security Information Environment Management, which is the tool that monitors your entire network. It reports back to you as to what exactly the user is doing, which software needs to be updated, which computer needs updates, which systems need new applications, which systems needs updates. So all the things like that, like the system that we looked at, it monitors how your network works. It monitors your network, and then it gives back a kind of a report to you as to what exactly is happening from your network. So today, what I want us to mainly focus on is looking at the devices that you might find in a network. So I just want to go through first the devices that you will need when you're building a network. Which devices are those that you will need when you're building a network? Let's say you have a contract, right, to build a network, maybe for 20 users. Which devices do you think we want to need in order for us to build a successful network or a running network? Anyone wants to answer that? The devices that we'll need in order for us to be able to build a network. Wow, so you guys don't know any one device that we can use maybe to build a network, or any device that can be required when we're building a network for any client. Let's say we have a client that is like maybe 20 users. They want us to build a network for them. Which devices do you think we need for this client? Kidibone?
Hi, Melissa. I'm not sure. I'm trying. I think it's a fax machine or a
Fax
printer.
machine. All right,
Yes.
printer. Yeah.
Yeah, that's what I think.
All right, so basically those are all the devices that we need. Okay, that's not all. There is just like the few of what we'll need in order for us to build a proper network, right? So first device that we need to know about is the router. Okay, let me slow down. Let me not go to that part. Let's start with the design. So as you can see on my slide, it says monitoring and tuning of the network ensures operation and performance meets the manufacturer's and organizational specification, right? So design, what is that, the design when it comes to networking? What do we mean by when we're saying design? So first, when we're building a network, right, we first build a network based on a client's requirement, right? So we say now a client comes to us as Retro Rapids learners and says, okay, they want us to build a network for 20 learners, right? So every time when we're building a network, we build a network based on the client requirements. That's the first thing that's the first step where we start from, right? Building a network based on the client's requirement. So the client will tell us, okay, the number of users, right? The number of users that are going to be connecting or using that network, right? And then maybe the purpose of that network, why exactly are they building the network? And then how long is the network supposed to last in that place? We once had a client who wanted like a wireless network, right? And then they said the network was going to be in that area or in that building for like 3 months because the project was only for 3 months. So we looked at that. We built a network based on the requirements, or we designed a network based on the client requirements. So the client will tell you, okay, what exactly are they looking for? What are their requirements? They say we said number one is the number of users that are going to be using that specific network, and then also the purpose of the network, right? Why are they really building this network, right? So that we'll know, okay, if it's a permanent project, if it's a permanent building, right? We know, okay, what type of devices are we going to use, and then how are we going to crimp the devices, or how are we going to lay out our network, because it's a permanent structure, or it's a permanent network. If it's a temporal network, then we know, okay, which media are we going to use so that it will support the requirements of the client. So before we start designing, the number one step is the requirements. So number one step is requirements, the client telling us. So we sit down with the client, and then the client will tell us, okay, what type of network are they do they want, right? Sometimes the client doesn't know what type of network they want, but they just note, okay, here are their requirements. They want a network for 20 users, and then the project is only for 3 months. And then the budget is very low, so they want the devices that are cheaper. So when you're buying devices, you have to make sure that you buy devices that really support the client's budget. So that's number one. And then when we're designing a network, so once we have the requirements, once the client tells us exactly what are their requirements, we move to design. Right. Designing now is based on the information that we received from the client. Says, okay, they gave us the requirements. They said the number of users, and then it's a temporal network. So we know, okay, we don't have like to run a lot of cables. If it's a temporal network, why can't we rely on a Wi-Fi network? And then if there are devices that really need Ethernet cables, or that really need wired cables, then we can just like plug in those cables for those devices that really need cables. Right? So everything that we do it based on the requirements, the client requirements. And then we design that network that caters for the number of users, or that caters for the requirements that the client has specified. So we have so many tools that we can use to design our network. Today, I have like a network simulator, the one that will really show you how the network is going to look like before we even start building that network. So sometimes we can design a network and then give the design to the client, or give the design to the user, or whoever is in charge of that. But most of the times we give our design to the client and then say, okay, here is the design. Do you think, are you happy with this specific design? But most of the people, they're not even keen about networking. So they won't say, they won't complain about the specific network that we have designed for them. They'll just look at the design, and then most of the thing, what they will be interested in is the budget, right? Because they will give you the budget and say, okay, this is the money that I have. Sometimes you have to work around the budget of the client and say, okay, if this is the amount of money or the budget that has been allocated to this project, then which devices am I going to buy in order for me to cater for this client, right? So sometimes this constraint when it comes to the design of your network might be maybe time, right? Also might be the budget, right? So these might be the other constraints that come into play when you're designing your network, right? So you have to keep this in mind when you're designing a network to say, okay, the time, how much time is the client giving me, right? And then also number two will be the budget, so that I know which devices do I have to buy and stuff like that. Because when it comes to devices, we have things like licensing, we have whereby you buy a Cisco device, and then you have to pay for licensing for that specific device. Or sometimes you buy a Microsoft Office 365 tool, and then now you have to pay a certain amount of money. So if they say the project is for 3 months, we know, okay, I only need to pay for 3 months, unlike when you purchase a license for an annual or for a year, right? So if the project is for 3 months, then you know, okay, I only need a license for 3 months. So those are the things that come into play when you are designing your own network. So first, number one, we said, is the requirements, right? The client will tell you what exactly the network is all about. What are the requirements? Why are you building the network for? And then we move to step number two, which is the design. So the design part is us now looking at the client's requirements and say, okay, these are the requirements, and then this is the network that I'm going to build for you. And then number two will be installation. So on the design, we look at, okay, let me show you maybe a bit of a design that I have here with me, a design that I have of an alt network for a store. of a network that I have on my site. Let me see if I have this. All right, can you guys see my devices, my network there?
Yes.
Yes.
All right. So this is maybe how you can design. Let's say maybe the requirements from the client is that there is a store, right? Let's say maybe you got a contract from any, maybe let's say Caspar is building his own shop for his new shoe, right? For his new sneakers, right? So you have to build a store for him. So he comes with the requirements and tell you, okay, he needs maybe 3 branches. As you can see here on my side here, I have store number 1, I have store number 2, I have store number 3. So these are the branches in different areas. Maybe I have a branch in Soweto. I have store number 2, which is maybe located in Tembisa. I have store number 3, which is maybe located in Centurion, right? So these are all of the stores. So the requirements of the client was that they wanted maybe 3 stores in 3 different branches. And then they tell you, okay, all of those 3 stores, they must be connected to a server so that maybe store number 1, they can be able to go on the server and check it, okay, sneaker size 7, is it still available on the warehouse, right? So all of these stores, they must be connected to this server that you can see, server 0 down here. So if all of these stores are connected to the server, okay, here are the stores, right? Down here is the headquarters. So this is the business headquarters. Maybe let's say his headquarters is maybe in, let's say in Sandton, right? So this is the headquarters. And then the server is the one that is the information about the available sneakers in the store or in the warehouse, right? And then here are the laptops for the accounting department, marketing department, production department. So this is the headquarters located or situated in Sandton. And then down here, we have different stores, right? Store number 1, number 2, number 3. And then you know that most of the times when you go to a store and then you say, okay, you're looking for a sneaker number, a sneaker size 7, right? They have to check on the system that if do they still have that sneaker number 7. If in this store they don't have number 7, they will try to check if store number 2, the one in mid-range, does it have that sneaker? So where is that information stored? That information most of the times is not stored on that shop per se, right? So this shop, they use these computers or the system that they use what you call the point of sale, which is a till, right? This till, the point of sale, communicates with the server and then try to check on the server if the server, if store number 2 still has the sneaker size 7 available in their store. And then if it's still available, that's when the cashier will tell you, okay, in store number 1 or in mid-range, we don't have sneaker number 7. But if you go to Tembisa, store number 2, they do have this sneaker. So, because all of this information is interconnected to each other, right? Like they share that information. They are connected to a server somewhere. So how did we do this? We designed this network based on the client's requirements. So that's their requirement number 1 was that all of the stores must have access to the sneakers that are available on the warehouse. So all of the stores, they must be interconnected to each other in a way that store number 1, the cashiers must be able to tell if store number 2 still have the same stock in their warehouse, or store number 3, do they still have the same stock in their shop, right? So that's how it's designed. So that's what, number 1, that was the requirement from the client, right? And then we build or we design this network based on that. So without the requirements, it's really difficult for us to design any network. So now this is a Cisco network simulator, which some that can use it to kind of like design their own network, right? To see, okay, so before we start any installation, like any physical installation, we need to have like a design phase created. We need to create a design so that we see, okay, how are we going to lay out our network? We call it the topology. Which type of topology are we going to use? Which is the laying down of the network. So store number 1, you can see, okay, there's our store number 1. They will tell you, okay, store number 1, how many till points are they going to need, right? If it's 3, on this side, you can see I've built 3, and then that side I built 3, I built another 3 on the other side, because they say, okay, the till points is only going to be 3. So on this computer here, there is a software called the point of sale, right? So if you check on most of the shops, they go, if you have worked as a cashier, you note, okay, each and every shop, they have their system whereby you log into, and then that system communicates directly with the server somewhere, right? The server is the one that contains information about the stock that is available in that organization. So every time when someone else uses what we call a barcode scanner, and then someone pays for that product, the product gets removed from the server, meaning that, okay, if we had like 20 sneakers and then someone else buy one sneaker from store number one, and then we use a barcode to scan that, and then the system now, once someone pays for that, the system will pick up that, okay, this shoe has been removed out of our system. So now, since we had 10 sneakers, now we are left with what? With 9 sneakers. So that software that we have on this store, we call it the point of sale system. It communicates with the server. And then every time someone buys something, it gets cleared from the server and say, okay, this one is gone. And then now, this is how we keep track of the number of products or what you call equipment or whatever we have on the warehouse, or groceries if it's Checkers or ShopRite, all of those shops, right? So it keeps track of what we have on our systems. So sometimes some stores, what they will do is they will say, okay, they need a separate server for each store. But after that, all of these point of sales, they must have access to all of those servers. But the requirements for this client, they said, okay, the budget is very small, right? So we're working on a tiny budget, on a small budget. So they said, instead of like us having 3 servers, let's have one server from built at the headquarters. And then if that server is at the headquarters, then all of these other stores, all of these computers, they must access that one server. So again, the constraint was the budget, right? If our client had enough money to pay for 3 servers, so what we're going to do is we're going to install or configure servers on within each and every store. But now it's just that we're working on a tight budget, so that's why we have built only one server from the headquarters, and then all of these computers, they communicate directly with the server on this side. So that's why we have that there. All right, so that's how you design a network. So we have designed our network, we have tested these. So the other thing is the IP addresses. So we choose an IP address range, and then we try to see, okay, will this IP range accommodate the number of devices that the client have requested? For this scenario, the client have requested for 3 computers, right? Said, okay, they're only going to use only 3 tills. If now, and then the IP addresses that we choose, the IP range that we choose, it must be an IP range that allows us to scale up our network. Let's say now the client comes to us and say, okay, instead of 3 tills, our store has grown now. So now we need about 10 tills. So the IP range is supposed to support the growth of the network. So when you're building or when you're designing your network, whatever network that you're building, it must be scalable. Meaning that when the company grows, your network must be able to grow with that network without affecting the current users. Right? So let's say this store number 3 started with, let's say, this is Drift, right? Let's say this is Drift store number 3. They have only 3 tills, but now they've noticed a growth in their store in Tembisa. So now they say, okay, we want to grow our store, we want to enlarge our store, right? Instead of only 3 till points, we need 6 or 10. So I'm saying now, based on your design, when you're designing your network, you have to also consider that the type of network that you're building must be scalable. Right? So these are the terms that you're going to hear when it comes to networking, right? Scalability. So scalability is all about the network being able to grow without affecting the current users. So when you add more users to your network, it mustn't affect the way your network is running at the moment, or it mustn't affect the current users that you have in your network. Does that part make sense? Are you guys listening? Can you guys hear me?
Yes.
Yes, sir, we're listening.
All right, so that's what the design is all about, right? The requirements and then the design. So we said it start with the client, right? The client giving you their, telling you their requirements. Why are they building the network for? What's the main reason for this specific network? So we said here, the client said they need 3 stores, and then those 3 stores, they must connect back to the headquarters, where the headquarters is the one that is the server for all of the products that we are selling, for all of the goods that we are selling, they are stored on the server. So every time we use a barcode, or every time we scan any product, the server releases or removes that from the system, or picks up that, okay, this thing has been paid for, meaning that it's out of the warehouse, and then keeps track of the goods that we have, right? So let me just minimize this and go back to my slide. So we have the number 1 point was the requirements, right? Before we start building any network, we start with the requirements. The client has to tell us, okay, why are we building this network? What's the reason for the network, right? And then number 2 was the design. So we have gone through the design. We looked at the design and said, okay, when you're designing your network, there might be some constraints, like the time that you're given to build your network, or the budget. You might be working on a tight budget, and then also maybe sometimes it's not only the tight budget, it might be also put in mind that the network that you're building is supposed to be scalable, right? So as the company grows, the network also must grow. Must also be easy to scale up your network. And then the second one is installation, right? So we said installation, you have to look at, is it a permanent store? If it's a permanent store, then we can run a lot of cables around, and then those cables support that particular network. If it's a temporary network, I always prefer going with the wireless, right? So make things easy for me. Like after 3 months, everything is done. I just take my routers, and then we leave. Nothing much that is to dismantle. I don't have to go through the roof, through the ceiling, and then running the cables and all those things, because it's just a 3 months project. If it's a permanent project, then I have to go via the ceilings, and then like what you call, lay down the cables and all those things. So installation is now us. We have bought all the devices that we need, and then now we're installing these devices that we bought, right? If you bought a router, you bought a switch, you bought like a firewall, you bought like an intrusion detection system, you bought like a server. So now we're installing all of those. So the process of configuring or applying, or the process of installing that, we call it like the process of configuring that, we call it installation, right? So you're configuring your servers, you're configuring your routers. So that's the installation part. And then the other one will be evaluate networks, right? So once your network is up and running, we have to evaluate, we have to monitor it, right? So before we give it to the client, we have to monitor and see, okay, how is it performing? We have so many tools that you can use to monitor your network, the speed of your network. For example, let's say now I want to monitor the speed of this network. I can maybe run a network speed test. So you just want to find out the speed of your network. There are so many tools that you can use to monitor your network speed. Let's say you're at home, you want to find out the speed of your network. As you can see now, my download speed is 82.4, and then the upload is around 87. Let me see. So you can see my internet is not bad, right? Like it's running proper, because I'm on download is 82.4, 87.8 is the upload. So my network is doing really good right now. All right, so there's so many tools that you can use to evaluate, to monitor, or to check. So the other thing is, let's say you have built your network, you've configured your network, right? You are in the process of testing it. We can do something called the baseline, right? So the baseline is you can use the AI to create like the baseline. The baseline is the process of us like looking at the network, how it's performing, right? And then saying, okay, you saw the speed that I have now, that I just showed you now. So where is that speed network? So baseline, you're saying, okay, first week, my network is performing this way, right? You keep record of how your network is performing, maybe for the first week or the second week. So you keep a record of that so that, like, let's say maybe after 3 months, you can now refer back to the baseline to say if there are now any changes, right? The baseline is the one that will tell you, okay, there are changes, because you'll be comparing what's happening in 3 months and then what was happening in the beginning of the network. So the baseline is just like you recording how your network is performing in the beginning, right? At the first days when you built your network. So the baseline is the one where you're gonna, it's your referral point, right? Your reference point whereby you say, okay, in the beginning, my network was performing at maybe 84 MB per second, which was the download, and then the upload was 87 MB per second. So now you're trying to find out what has changed. Is it still the same, or there's changes, right? So the baseline, you can create a baseline, especially with your, you can also create a baseline with your, maybe your computer, right? Let's say you're looking at the performance of your computer. When you bought your computer, when it was brand new, you know that it was performing fast, right? And then after a year, it becomes slow. Then you start complaining, saying, okay, your computer is performing slow. So that means you have a baseline, right? You know how your computer was performing before, but now it has changed. So you are comparing the current performance to the state it used to perform when it was still new. So that part, the first part, you can create, or we can call it the baseline, knowing your network, how it performs in the beginning, so that when things change along the way, you can compare what you have now with what was happening in the beginning. So that's the baseline. And then we have a term called the benchline. The benchline mostly is maybe a standard that has been set by many organizations to say, okay, the standard for a network to perform for an organizational network is supposed to be maybe 100 MB per second, most of the times, 100 MB per sec. So that's what you can, that's the benchline. You say, okay, this is the standard that has been stipulated or that has been set by different organizations, right? So baseline, it's us, it's you as the network administrator creating a baseline or a point of reference to say, okay, if things go change after 6 months, do I have like a reference point to check, okay, how was it performing before? So that baseline, it becomes comes in handy for you to tell, okay, is there any change within your network or not? All right, design and install. Okay, that's it. And then planning and designing. So first we have to plan planning and design. So that's the part I've spoken about. The planning phase is you now, you have the requirements, and then now you have to plan for your network, right? They told you the requirements, then you have to sit down and plan which devices are you going to buy, what type of topology are you going to use. So the other term that you're going to hear a lot when it comes to networking, right? It is called topology. Topology is the laying down of your network, right? How are you laying down your network? The design of your network. So going back to the slide or going back to the packet tracer, you can see what I have here at the top at store one. At store one, what I have is called a star topology. That part, I call it the star topology. Like I'm looking for something. All right, so what we have there, we call it a star topology. We're going to break it down, the different topologies that we have. So here it is, network topology, right? Topology is a term that refers to the shape of the network and the layout of cabling from a bird's eye view, much as floor plan identifies the layout. So just the topology, just know that it is the laying down of your network, how you're designing your network, right? How your network looks like. So that's just a topology. And then we have what we call the physical and then the logical topology. Let me see if I can show you the physical. So now on this topology, we call this the logical topology. The physical, let me see if I can build a physical. Okay, let me see if I can show you the physical. So physical, this is how it looks like physical, right? So this part, we call it a rack, right? So you can see at the top, I have a router. There's another router there. There's, what's this? Is it a router? That's a router number 7. I have another router number 5. And then here I have a server. I have another server. So let's say you're working for any organization, right? This is how the physical topology looks like. This is how the network looks like in any organization. So when they're talking about a server room, right? So if you go to a server room, you find something called a rack. And then on the rack, you will see there's a router, there is a server. Here, this is a switch. You can see there is a switch there, and then that's a router there, what we have here. At the bottom, I have a wireless device there, which looks like an access point. Okay, this is an access point. And then this side, I also have another access point, right? So when talking about the logical topology, this is what we're talking about, logical topology. So this is a logical topology from a bird eye point of view, right? Physical, it looks like this. This is what you're going to be working with. When we're talking about the physical cabling, this is what you're going to be dealing with a lot. Right, that's the logical. All right, network topology, and then we have this part, physical and logical network design. Okay, I've showed you this part, right? The physical and then the logical. How does it look like? So physical, I showed you the logical. I've shown you that part. Okay, we have different, what does this? A logical layer shows all logical aspects of the network. This includes logical networks, assigned IP addresses to various hosts and devices. So there are some other terms that you're going to hear a lot referred to in the network, right? We have what we call a host. A host, what is that? What do you think a host is when it comes to networking? Oh, sorry. A host device. Camino. Camino. Okay, we got people that just log in and then leave like the network.
Sir,
Yeah.
the host, we can say it's the device that connects all the devices.
So you can call your PC a host, right? A host device. You can call the desktop a host device, right? So those are devices that we use to connect to the internet and stuff like that. So the other term for host will be end device, an end device, right? And then the other term will be, sometimes they will call it a client. Right. The other term will be, so we have host devices, we have end devices, a client. So there's so many terms that you're going to hear once you start working in an IT department. Some they'll call it a client, but they're just talking about the desktop, the laptops, maybe your tablet that you use to connect to the internet. So those are the things that they're talking about. Or the other term is a workstation. So they'll be talking about the same thing, right? Host device, end device, client, workstation. So just know that they're talking about just the same thing. All right, so here are the things that you have to look out. If it isn't broke, don't mess with it. When in doubt, reboot. So most of the times, the systems, if you reboot, if the system is failing or is malfunctioning, if you reboot the system, it kind of like clears those errors, and then the system will start normally and then start functioning again, right? So the other way of troubleshooting or fixing the errors is rebooting the system. Rebooting the system is the term. It's just like, it means restarting your machine, rebooting your machine, switching it back on. That's what it means to reboot a machine, right? And then network performance problems are resolved according to organization specification. So on Monday, with this other group called XON, we're talking about following organizational policies and procedures. We said when it comes to troubleshooting, every organization has a policy and procedures that everyone have to follow, right? So that policies and procedures, they are not only there to protect the organization, but they're also there to protect you as a technician. If something is to go wrong, while you have followed the policies and procedures, then you can show them, okay, I really followed all of the steps, all of the policies, and all of the procedures that have been stipulated by the organization, but things, they just went wrong. So you are protecting yourself and then also protecting your organization. So make sure that every time, so once you are employed by maybe, let's say, Retro Rapid, they take you there at their premises, and then they say you are going to be one of their IT technicians. They will show you their policies and procedures when it comes to the IT department, or also troubleshooting, right? So that you will protect yourself and also protect the organization. So you have to make sure that every time when you are conducting troubleshooting, you follow the company policies and then procedures. So what are the policies that they might come up with, or what are the procedures? So some companies will tell you, okay, before you make any changes to a system, right, you have to create a backup. Let's say you are fixing a hard drive issue on someone else's computer, on a user's computer, right? They say, okay, the first thing that you do, back up the information so that if the system get corrupted, you know, okay, you have the backup of the data. So that might be the other policy or a procedure that you have to follow when troubleshooting systems. That might be part of the policies, right? And then some organization, they might give you the backup guidelines. How do you back up the systems, right? For example, the store that I showed you, the products that are in the warehouse, if the server had to fail, okay, let me go back to the slide, to the packet tracer. So you all now can see my packet tracer, right? And then you can see now these all three stores, they are relying on one server. Let's say this server was to malfunction or something has to go wrong with this server. What effect is it going to have on all of these three networks, on all of these three stores? If the server has to go down, if the server had to fail, what effect will it have on other stores, these other three stores? Hendrik, what's your answer? Hendrik, what's your answer? Kabelo? Goodman? Wow, looks like no one is listening. Okay, let me go ahead. Let me just go ahead with this. Okay, backup guidelines. Each and every, okay. Yeah, Kidbon.
Melis, can you please repeat the question? You're saying that if Adristos was relying on one server, then the
Yeah,
then
what
that,
impact will it have on other stores if this server had to fail?
I think this if that server has to fail, then the impact that will be on these restores is that they wouldn't have anyone to supply for their products, and I think it will have an impact when it comes to their jobs will be on the line. I think something like that. Yeah.
Okay, thank you. Charity, what's your answer to that? Charity? All right. Okay, we got people that are not listening, right? I think I have to come up with a plan of stopping a stipend, stopping the stipend of the people that are connected but are not listening. Okay, let me call someone else, try to find out who's listening. Lindo, Okay, not listening. Luyanda, can you hear me? Rivonia? Ntobeko, can you hear me? Ngobile? Oratile?
Yes, sir.
I can hear you. It's Mobile.
Yes, sir.
Sbusiso? Yeah, going forward, this is how I mark my register now. All right. So Ngobile, you had my question, right? I said if the server had to fail, what impact will it have on the other stores?
I think it will affect the operation.
Hello.
Can you hear me?
Yeah, I can hear you.
I think
Sir,
it will
can you hear me?
affect the operation to the other stores, and it will affect their jobs and decrease the productivity.
Right, here's my point, right? I said the server.
Sir?
What's the reason? Yeah, Luyanda, I can hear you.
Yeah, okay. I was saying I'm present, but then I cannot see you.
You can't see me.
Yes.
But can you see my slide?
No, I'm only hearing voices.
What, you using a laptop or a phone?
Phone.
Okay. I'm not sure what my. I'll try to disconnect it, then connect again.
Okay.
All right, so guys, as I was saying, right, like the server that we have here, server 0, it contains the information about what we have in the warehouse, right? So store number 1, let's say store number 1 have like 20 sneakers. That information, the barcode of all of those sneakers will be stored in the server. Store number 2, the information of the product that they have will be stored on the server number 0, right? And then store number 3 again, the products that they have are stored on the server. So these computers, what they're using them for is just for them to access the information that's on the server. Let's say, for example, you are paying for something. So and then they scan that specific product. If it's scanned and then paid for, then the system now, the server will remove that specific information, that specific sneaker from the system, right? So now if the server is down, this store won't have that information of what exactly is happening within the server, and then the server now will not be able to pick up with, okay, this thing have been paid for, is out, and all those things. So we need a backup of this. So we need maybe not only one server, maybe we need like 2 servers. If this server is to fail, then we rely on another server. That's why I said, okay, if the budget of this store allows us, we're going to put, let's say, maybe 3 servers, 1 server for store number 1, 1 server for store number 2, and then another server for store number 3, so that all these stores, they can have their own servers, right? And then maybe we have this server, this side, which has the information about all these stores, right? So that when store number 1 wants to check if store number 2 has a certain product, then they communicate directly with this server. This server checks with the store number 2 and then says, okay, this is still available in stock or it's not available anymore, right? So that's why we need a backup. A backup is just there for fault tolerance. So these are the terms that you're going to hear a lot when it comes to networking, right? The first term that is important that we spoke about is scalability. To scale up, being able to scale up your network. As the company grows, you must be able to scale up your network. And then number 2 will be fault tolerance. Fault tolerance is to say, if this server fails, right, we don't want to stop production, right? We don't want to stop production. So we need a backup. So that this server fails, we need another server to take over so that the company can continue with production. So that term, we call it fault tolerance. So your network is fault tolerant. If something goes wrong with one server, we can rely on a second server. So that's what we that's what we call fault tolerance. So we can rely on a second machine. All right, let me fight back to this part, the backup guidelines. So each and every organization will have their own backup guidelines, right? Especially we have systems that we call them critical systems. For example, on this network, we have made this server to become a critical system, because if this server now fails, it affects the entire network. So the critical systems are the systems that the company or the organization or the network relies on a lot. So this server now, server 0, has become one of the critical systems. So if a system is called the critical system, we need to make sure that we monitor and also we do a backup for that critical system. So monitor and then also do some fault tolerance if the system is a critical system. So backup. So in many ways, backups are the heart of any design of a critical systems, right? So that's what a critical system is. Yeah, sure, Hendrik. Hendrik, you have a question?
Can you hear me?
Yeah, I can hear you.
Oh, no, there was something wrong with my mic. So why has it become a critical system now?
So it's a critical system because it carries the company information, like the imported company information. For example, this system, right? We said
Yes.
Information about the stock or the product that we have in our warehouse is stored on this server. So now
Yes.
these till they communicate with the server to find out, okay, which product is still available on stock. So now if this server is to fail, that means now it affects the production of all of these 3 stores. So that's why we call this what? A critical system. It's a system that carries company sensitive information or the one that the production relies on heavily.
Oh, okay. Okay. Thank you, sir.
And then the other thing, you can also call this server, this router, a critical system. Let's say if this router fails now here, that means there won't be communication between these networks and then this one. So any system that carries like critical or imported information or line of information, then that system we call it critical. So we have to come up with the backup options or fault tolerance options.
Oh.
If it fails, then we have like a plan B
Okay.
for that.
Oh, okay. Thank you, sir.
Okay. So backup guidelines, they are there, and then mirroring does not replace backup. So mirroring is a process of keeping a copy of a certain information, right? So it does not replace backup. So backups is also having like a copy of that actual information of the database. So the most common use of restores is after a catastrophe, regularly test your ability to restore. So when you are conducting technical support, right, or system support, you have to make sure most of the times when you sign an SLA with the client or service level agreement with the client, we promise the client a 99% service, right? Meaning that the system will be running most of the times. So we try by all means to avoid a downtime. A downtime is whereby these stores, a downtime is whereby these stores now, they can't access this server. So there's a breakdown along the way, so which affects this store. So that part, we call it a downtime, whereby the users or the cashiers, they can't access the information in order for them to carry on with their everyday tasks. So we call that a downtime. So your network must always try by all means to avoid a downtime. So you must have like the fault tolerance, the redundancy, what you call the backups, to avoid system failures, or to avoid, okay, not to avoid system failures per se, but to avoid downtime. Because the system might fail, but we must have a backup, right? Another system that supports the system that has failed. All right, backup management headaches, right? When it comes to backup, you have to make sure that you back up all the information. Okay, there are some information that really deal with critical information, whereby you have to have like the exact copy somewhere stored, so that if the system fails, then the other one kicks in. So we have different types of backups. We're going to talk about backups. I'm not sure which module is it. All right. Managing network traffic during backups. Okay, my question would be a LAN. What is a LAN? What do you think a LAN is? What do you think a LAN is? A LAN, local area network. Can you describe a LAN for me? Mobile?
A LAN is a network that interconnects computers within a limited area. So areas such as like schools, residents, yeah.
Yeah, so you said?
No, I'm saying it connects it interconnects computers within a limited area, such as schools, residents, and etc.
Yeah, so that's the LAN, right? LAN, local area network is found in one geographical area, right? So it's in a limited area. And then the WAN will be the opposite of that. Like, so the WAN covers a large geographical area. So, and LAN connects, interconnect, a WAN connects all of these LAN networks. So all of the LANs you find, once you connect maybe 3 or 4 LANs, then you have yourself a WAN network. But a WAN, it covers a larger geographical network. For example, now a advanced assessment here, we have a network. We have another branch in Cape Town and another branch in Durban. So all of these 3 branches are connected to each other, right? So we call that a WAN. So here in Joburg, we have a LAN, which is in one geographical location, and then it's limited to a smaller radius, right? And then we have another one in Cape Town. We have another one in Durban. So once we interconnect all of those, we have ourselves a WAN. Okay, so I just want to go through this slide, right? Network representations and then topologies. Now, I want to ask a question. What is a topology? What is a topology?
So,
Yeah?
topology is the laying down of network or
Right. It's
the
just
design of network.
the design, right? The design of your network, the laying down of your network, right? So that's a topology, right? Now, I just want us to go through different topologies that okay, a topology, we said is just the laying down of your network, right? So we have one called a star topology, right? A star topology, and then number 2, what's the other topology that you know of? Anyone wants to try?
A ring topology.
We have a ring topology, right? What's the other one?
Bus topology.
We have a bus topology. Yeah. Another one, any? We also have what we call a mesh topology. So a mesh topology is kind of like the combination of most of these topologies. Yeah, Kiribon?
Yes, and a tree typology.
A tree topology, right? So,
Yes.
so now you have to go through, maybe check online the advantages and then the disadvantages of those topologies, and also check out the characteristics of the topologies. But the most used topology, let's say in the most organization, is the star topology. And then some prefer the mesh topology. Mesh topology, you're going to find it used a lot in the one wide area network, right? We use mesh topology. A mesh topology is kind of like the combination of all of these. We take the advantage of a star topology, ring topology, bus topology, and then we kind of mix it right? So it's a mix of all of these other topologies. Okay, network representation and then topologies, right? So network topology, network diagrams, often called topology diagrams, use symbols to represent devices within the network. Important to know, term to know include a network interface card. A network interface card is the one that facilitates internet communication. So if you need internet access, then you get your Ethernet cable and then plug it to your computer, and then you get internet access, right? And then the physical port, I'm going to show you when you come back to class when we're doing like the face-to-face classes. So we're going to look at a router, the physical router, and then the physical switch, so that you know what is a network interface card, what is a physical port, and what is an interface. Okay, I told you about the terms that you're going to hear referred to these devices. You can see at the top there, we have end devices. What's the other term for end devices? What's the other term for end devices? Kidibone? Kidibone? What's the other term for end devices? We looked at like, I think 4 of them.
Yes, you said is an client or a workstation device.
Some they call it a client, some they call it a workstation. What's the other term, the last one? And
a host.
A host, right? So all of the devices that you see there at the top, the IP phone, the wireless tablet, they are called end devices, workstation, client, and stuff like that. And then we have the intermediate devices, right? We have the wireless router. We have the LAN switch. So the wireless router is the one that, let's say you want to build a wireless network, right? So you're going to buy a wireless router. A wireless router is the one that is mostly used for home networks. So every home that is a network at home, right? A network at home, the network or the route, the type of router that they use is the wireless router. And then the LAN switch. So a switch is just mainly used to interconnect many devices. So a switch is used to interconnect many devices. A switch is used to interconnect these end devices. Let's say your network consists of 20 end devices, and then you want to connect those devices to a switch. So the switch comes in, we have a switch that is 24 ports, we have a switch that is 10 ports, we have a switch that is maybe like a 15 ports, like what the one that I have here is a 24 port, and then the other one is a 48 port. So we have a switch that is different ports. And then a router, so we have a wireless router and then a router. So this one has no capabilities of wireless, right? It just provides you with the internet access with no access for wireless. That's a router. So the router is the one that takes you out of your own network to other networks. We call it a gateway. For example, let's say here at Advanced Assessment, we said we have like 3 branches, right? We have the Cape Town branch, we have the Durban branch, we have the they kept those 3 branches, right? So in order for us to interconnect all of these branches or to communicate, to facilitate communication between all of these branches, we need a router. A router is a gateway, is the device that takes you out of your own network to other networks or from your own network to the internet, right? So if you have a router, if you don't have a router in your network, and then you only have the switch connecting all of these end devices, all these end devices will be able to communicate with each other, but the problem is that they won't have internet access. So when you need internet access, then we buy a router. Either we buy a wireless router or we buy this router. So the router is the gateway or it's a device that takes you out of your own network to other networks. Yeah, Kidbone?
Oh, I wanted you, Melissa, to repeat the gateway. What does it mean? I wanted that part.
Okay, so it's just that the router basically it takes you from your own network to other networks. It's mainly used for that.
Okay, thanks.
All right. And then we have what we call the network medium or a medium, right? So a medium is, I think we spoke about these, the different mediums, right? Did we? We looked at the Ethernet cables, we looked at the serial cables, the wireless, the advantages and disadvantages of that. We did, right? I think
no,
I did.
we didn't.
No, sir. No,
No,
sir.
it's
No.
not us. Yeah,
All
No,
right.
maybe
sir. It was not
another
us.
group.
So
Probably it's another
basically,
group.
basically a
didn't.
network medium or a network medium is a cable or a means that transfers data from one device to another device. Let's say, for example, you are on a call, you're calling me, right? Like right now, right? So the medium is the line or is that line that allows or that takes data from one computer to another computer, right? Let's say okay, let me go back to this part. So you can see on this part here on store number 1, we have a computer, a desktop that is called store 1.1, right? So what exactly that connects store 1.1 computer to this store 1 switch? It's an Ethernet cable. So that Ethernet cable, we call it what? A medium. So a medium is a cable or a device that carries signal from one computer to another computer. So it's just a device or anything that carries signal from one device to another device. Okay, so that's a medium, right? So sometimes wireless is another medium, right? So wireless, you can access internet using the wireless router. So wireless signals are the ones that take maybe signal from they take like information from your computer and then transmit the signal to the router or gives you access to the router and then you gain access to the internet. So that's the medium. All right, a topology, now you can see a topology. A star topology is the one that is like a central device that interconnects all of these. Okay, physical topology diagrams illustrate the physical location of intermittent devices. And then the logical topology diagram illustrates devices, ports, and then addressing scheme of the topology. I've showed you the difference between physical topology and then the logical topology. And then we have different types of networks, right? We have what we call the SOHO network. SOHO's network stands for small office, home office. It's the one maybe that consists with 10 users. We call it what? A SOHO, small office and home office network. And then the small home or the home network is the one whereby we have one router and then you have like 3 or 4 people connected to that router and that network. It doesn't have many protocols that are running there. It doesn't have many softwares that are running in there, right? And then we have medium to large, which is what we have here at advanced assessment, right? We have a medium network here, and then we find that ABSA is like a large network. You find that FNP, they have the large networks, and then the worldwide is whereby now we connect these LANs together, and then you have access to different resources in the internet. That is what we call the worldwide. So as you can see there, the small home networks connect a few computers to each other and then the internet. And then small office, home office enables computers within a home or remote office to connect to a corporate network. And then medium to large networks, many locations with hundreds or thousands of interconnected computers. Right, so these are the different networks. Network comes in different sizes. And then we looked at the LANs, right? Network infrastructure vary greatly in terms of sizes of the area covered. So we said the LAN covers one geographical area, and then also varies in terms of like the number of users connected. A LAN has like fewer users connecting, unlike when we have like the one. And then also they vary in terms of like the number and the types of services available. But we use different protocols and different services when it comes to LAN and then the one. Area of responsibility. So LAN, we said it cover one geographical location and then a small geographical location. And then we said a one covers a wide geographical area. So that's the difference between these. So they vary greatly in the size, the number of users connected, the services that they use, and then the area that they are responsible for. And then we have what we call LANs and WANs. Okay, still continuing with that. LAN interconnect end devices in a limited area, right? That's the LAN, characteristics of a LAN. And then LAN are administered by a single organization or individual. So you find that most of the time the LAN is managed by maybe one network administrator is the one that is in control of that specific LAN. And then we have the other characteristics of a LAN, which LANs, they provide a high-speed bandwidth to internal devices. Sure. Let me check if I have one. Okay, I do have one somewhere. APUSP. So, skip pocket tracer. No, it's not the one. Where is the another one? They're creating VLANs and stuff. Come on, where is it? I can't find it, man. Like I had this somewhere. I don't have it back up. Packet tracer. I have to download it from Edge Academy. Let's see. My password is wrong. Where is that? Looks like I forgot my password, but I can't go through. But I downloaded this one. So awesome. All right, what should I say to you? Because I have it to you. Singabashuni sasa angeke beze futhi. Shall I see basic? Yeah. Because abazi lutho laba. All right. Okay, guys, I'm back. Sorry, here to do something. Okay, so these are the characteristics of a LAN. We said interconnect end devices in a limited area, administered by a single organization or individual. And then they also provide high-speed bandwidth to internal devices. And then here's one. And one is a network infrastructure that spans a wide geographical area. Interconnect LANs over wide geographical areas, typically administered by one or more service providers, typically provide slower speeds links between LANs, right? So those are the characteristics of a WAN and the characteristic of a LAN there. All right, and then the internet, blah, blah, blah. So that's the internet there. The internet is the worldwide collection of interconnected LANs and WANs. LANs are connected to each other using WANs. And then also a WAN may use copper wires. So these are the types of mediums, right? The ones that carry the signal. Copper wires, fiber optic cables, and then wireless transmission are the mediums. So the internet is not owned by any individual or group. The following groups were developed to help maintain structure on the internet. So nobody owns the internet, right? It is just you have like the organization that kind of control what's happening on the internet, which is the ITF, ICANN, and then IP. Where's that part I wanted to go through? All right, there is the LAN and then the LAN software hardware. Let me see what I'm missing now. Network diagrams. Okay, I've showed you the different network diagrams, like network cabling documentation, network OTT. All right, let me switch to. So here's the formative, right, for module 5. Question number 1, list 2 examples of resources which may be managed in a LAN. Two examples of resources that can be managed in a LAN. What are those? Which are those resources? Yeah, Kirimon.
Oh, Melissa, a router.
Yeah, that's a router, right? What else?
Yes. A printer.
So those are all the devices. At least 3 typical examples of access roles. So access roles, right? Let me do this. Let me just quickly turn it on. Access roles. I want to break down the access roles. What exactly that is. Access roles. So list 3 typical examples of access roles. Anyone wants to try? So when it comes to access roles, right, like the system will look at yeah, Kidmon.
Oh, Melissa, I wrote a mandatory access control and a role-based access control and a discretionary access control. That's what I wrote.
So what is role-based access control?
I don't know. I just wrote those.
So you see, that's why I don't want people to just answer this question. They just find the answers online But if you really ask them what that is, nobody they can't even tell. Okay, what is that role access control? So role-based access control. So we in a network, right? Let's say you've designed your network, right? Let's say, let me go back to the slide that I gave there. So let's say we have store number 1.1, store number 1.2 there, store 1.3. So access role-based access control is we have so many users in our network, right? Maybe 20 of them, but we don't want everyone to be able to access everything in our network, especially when it comes to the banks, right? Banks, we have people that have different roles in the banks, and then they have also they have different authorities in terms of, like, maybe some they have the authority to grant loans, some they have maybe they must have access only to resources like applying for a loan. Nontobeko?
Hello, can you hear me?
Yes, I can hear you.
Yes, I said that role-based access control is the access based on roles and responsibilities of employees in the organization.
Right. So that's it, right? Like, let's say we have people that are working for finance department, people that are working for HR department, people that are working for IT department. So all these people, when we're using role-based access control, they must only have access to the resources that they need to perform their everyday task. That is role-based access control. Right. So you only have access to the resources that you need to perform your everyday task. That's it. I think there was a time, is it yesterday, where Adrian spoke about the least privilege or the least access control, right? Whereby we only assign you privileges or permissions to the resources that you need for you to perform your everyday task. So that is role-based access control. Kitibone, what was the second one that you said?
Oh, I said it's discretionary access role. Oh, Melis, I wanted to. So Melis, already you so I wanted to explain the role-based access role, but it's okay. And then you say, then I wrote discretionary access control and mandatory access control. Yeah, that's what I wrote.
So do you know what that is?
I only I only wrote the role. I only wrote about the role based access control, whereby you identifying a specific person doing a specific job, and authenticating them by looking at their identification, giving that person only the key to the door, or computing they need to access and nothing more. Yeah, that's what I wrote. And in the world of information security, would give that person or an individual a permission to get into a network via a username, a password, or allowing them to access to files, PCs, or other softwares that they need to do for a level of permission. That's what I wrote. Yeah.
Yeah,
I
that's
don't
it.
know.
Yeah, no, that's it. Yeah,
Okay.
that's what it's all about. Okay.
So Melissa,
So
you were asking the second. You were saying that in these three example of access roles, which one I wrote? I wrote the role based and the English mandatory access control and discretionary access control. Yeah.
yeah, so I just wanna so we have explained what a role-based access control is. So this
Yes.
let's say, as a system support technician, right? These are the things that we're going to be working on or doing every day, right? So you're gonna be identifying people from different departments and then give them access based on their role. For example, let's say you have people that you want to give permission to access maybe a printer. So what you do is you create a group, right? A group, and then maybe give it a name and say AC printer, right? So, and then everyone you put into that group, that means they have access to the printer. Or if it's not only a printer, maybe it's a server, or it's a software or a system that they need to perform their everyday job, right? So you create a group, and then you put everyone who's supposed to have access to that specific system in that group. So that group now, they have access to the system based on their role, right? Instead of like assigning user roles individually, we prefer to create groups. And then once we have a group, and then we put everyone in that group, and then everyone who's part of that group will say, okay, here are the permissions that you have. Does that part make sense? For example, at Retro Rapids, right, learners that I have, I think it's 23 or 22 learners, right? So instead of me now individually assigning permissions to all of you, right, which is a tedious work, it will take me forever to do that. So I can maybe create, like, let's say we have 3 systems that need to be accessed by you guys, right? But not all of you are supposed to access everything. So what I do is I create 3 groups, and then the people that are supposed to access maybe, let's say, a server, I put them in their own group. And then the people that are supposed to access a router, I put them in their own group. So which is, it makes my job easy in terms of like assigning these permissions to different people, unlike doing it individually. So it kind of like makes my work easy. Does that part make sense?
Yes.
All right, guys. So that was the first one, right? Which was the, okay, now let's move to discretionary access control. Discretionary based access control. So what is that you normally use for? What do you think that is? Non-Tobago, you want to try? We have 2 non-Tobagos in class, right?
No, it's me. It's the same person. Just that the other device is not working. I don't know. My mic is not working. But can I try?
Yeah, sure. Give it a try.
Isn't it the? Hello.
Yeah, I can hear you. I can hear you. Okay, I don't know what's happening with non-Tobago's network, but so discretionary access control is based on, let's say, the owner of the resource, right, is the one who assigns permissions to the people, right? So let's say let's say you own your phone, right? And then you give access to different people to say, okay, who has access to your phone? So that we call it discretionary access control, right? So you are the one deciding who's supposed to have access to this specific system. So the owner of the resource is the one that decides who does and does not have access to that resource. We call that discretionary access control. All right, yeah. Does that part make sense?
So
Makes sense, right? So basically the owner of the resource.
So,
Yeah,
so basically it's the authorization from the person that is
your mic is on mute, Nontobago. Okay, but basically is the person who's the owner of the resource, right, are the ones that decide who has access. That's what we call discretionary based access control. Yeah, Kidbody?
Oh, yes, Melusi, I want to say that can you actually probably do like tabulate them by I can say you can compare them with maybe you can compare 3 of them. Probably can say discretionary access control when you compare it with role based with when you compare it to role-based access control, this is what it does. Because right now I can hear you saying that discretionary access control is when the owner of the resources assign or give permission to a different people. Then with the role-based control, can you say role-based control is different from discretionary access control, or are they the same? Yeah, that's what I want to.
So yeah, it is different. Like the 2 are different.
Yes.
So with the role-based, you get the access based on your job role.
Yes.
What is
Okay.
stipulated. the shop role, yeah. And then with
Okay.
the discretionary, the owner of the resource are the ones that deciding to, okay, you can have access to this, or no, you can't have access to this.
Okay, thanks.
Yeah. And then what was the other one? You said 3 of them. The first one was the,
Is
you said role-based. Yeah.
and discretionary and mandatory access control. Yeah, mandatory. I don't know the way it's English never loved me. Mandatory, or is it English? Yeah, mandatory. It's mandatory. Yeah, that's
So this
the
one, the mandatory, mostly like it controls the owners of the resources, right? To say, okay, which permissions do you grant to certain people? So it's more of the control. It controls the owners of the resources. So we say the discretionary is whereby the owner of the resource decide who has access to that or grants access to different users to a specific system, right? Now we're saying the mandatory now, what it does is it controls the owners now of the resources. But who do they have to give access to? So that's what the mandatory is all about. So it's a security structure that restricts the ability individual resource owners have to grant or deny access to resources object in a file. So restrict the owners. Let's say you are the owner of a file, right? For example, let me see if I do have a file somewhere here that is open, or a folder. So if these permissions of these roles, you find them also on this system. Let's see, where is security? Okay, this is just the permissions there, previous versions. Okay, here are the other controls that we have. So let's say now I'm the owner of this resource, right? I'm the owner of this file, the folder that I just opened now. And then these are the other people that I have that I want to grant access to, right? So these are the permissions for a system. So full control, we're saying it allows the user to do whatever they want with this folder. And modify, they only have access to modify the file, read and execute. If it's an application, they can read and then also run that specific application. So these are the type of controls that we have. Read, you only have access to read information that is there. You can't alter it. Write, you only have like the option to alter. And then we have special permission. So mandatory, you are kind of like controlling the owners of the documents or the owners of the resource as to who have access to, who can they grant access to or deny access to. So discretionary, the difference now, Kidbono, we said the discretionary is whereby the owner of the documents, right, the owner of the resources, they assign permissions to different resources, right? That's the discretionary. And then now the mandatory is whereby we are controlling now the owners of the document as to who they can grant access to and then who they can deny access to resources. Make sense?
You said the mandatory the owners grant permission. Can you repeat that, please? The owners of the document.
So basically, the mandatory, what it does is we kind of like controlling the owners of the file or owners of the resources in terms of like who has access to grant or deny access to a certain resources. So it's a security structure that restricts the ability individual resource owner have to grant or deny access to resources or objects. So we are basically controlling the owner, right? To say, okay, who can you grant access to? Or then who can you deny access to?
Okay, thanks. Okay, maybe can you make an example? Let's say if you were the one to assign.
So let's say you own a file or a folder, right? The file belongs to you, right? And then now me as a network administrator, because I know there are certain people that I don't want you to give access to. So I control who you give access to a certain resource as a network administrator. Even though you own the file, even though you own a system, even though you own your computer, but as the administrator, I sometimes choose for you who you grant access to.
Oh, it's like you're a boss, like you you give.
I kind of like I'm above you, like I have
Oh,
higher
okay.
authority than you. Yeah.
Okay,
So you
thanks.
own a resource. For example, the folder that you have in your computer, maybe you own that, and then I now control who gets access to that. I tell you who do you have to give access to, and then who do you have to deny access to a certain resource. All right, so those are
Okay,
different permissions, different controls, that access controls that we have. We mentioned 3, there are more than that, right? Anyone who wrote a different one? Anyone who wrote a different one? Well, then the other access controls that we can talk about is the administrator and then the users. So the administrator, when it comes to computers, right? The administrator, you have full access to the system, to the computer, right? They can install, they can uninstall applications in your computer. And then we have others called the guest. The guest, they don't have access or they don't have control of installing any application or software in your computer. So let's say you borrow someone your computer, right? You don't want them to install any application. You don't want them to uninstall applications from your computer. You don't want them to make what you call theme changes in your computer. What you can do is you can give them the guest account or the guest access to your computer. So they will just use your computer, like maybe use Microsoft Word, Microsoft Excel, but they can't make major changes in your computer. So those are the access roles that we have. The administrator, we have the guest, we have like the super users, we have the power users, we have just a user. So we have many different access controls. All right, so you choose 3 to go with them. All right. Okay, number 3, list 2 methods commonly used to control access. Okay, we went through. Okay, we looked at the control access roles, and then now we're looking at the methods, right? Access roles. So down here, you can talk about, so Kidibone, the role-based access control, and then the discretionary, you can also add them on question number 3. And then on number 2, on number 2, on number 2, I'm only interested on the access roles. So you can talk about the administrators, the guest users, you can talk about the users, you can talk about the super users or the power users. And then all of the role-based access control, the rule-based access control, the discretional, the mandatory, you can put them on number 3.
Oh, so Melissa, basically you're saying that the answers that we just spoke about on number 2, we can use them in answer number 3. That's what you.
Because the role-based access control and then the mandatory, those are the methods, right?
Oh, okay. Okay.
So I would prefer them to be on number 3.
Oh, okay. Thanks.
Yeah, and then on number 2, we can use maybe the admin, the super user, the power user, which are the access control, like maybe to, and then the users, like maybe to control access to resources or to programs that we have in your computer, right?
Oh, okay.
So number 3, we're looking for methods. All right, let me see if I have more methods for number 3. All right, number 4, explain the meaning of the term access audit trail. What do you think that term means?
Well, sir, I think, sir, can you hear me?
Yes, I can.
Yes, I think it's a critical component of privacy and security monitoring. Sir.
Yes. Sorry. Yeah, that's correct, right? Like that was question number 4, explain the meaning of the term access audit trail. So audit trail, the trail we're talking about what the events that are happening in your computer, right? So if someone tries to log in into your computer, the system logs that information. If there's someone else who tries to log in your computer and then they put a wrong password, the computer logs in that logs that event. And then if, let's say, every time the system keeps information or keeps events of what's happening inside your computer. So access audit trail, okay, now I'm deviating from the access audit trail. So access audit trail is whereby we want to find out who, let's say maybe who deleted a file in a computer, in a system, or maybe who installed or who deleted or who uninstalled an application in a machine. So we can use the access audit trail. So the important part when it comes to this, to control access audit trail or to really manage that, we have something called the AAA. We have a process or control called AAA. We're going to go through that using Bucket Tracer. So AAA stands for authentication, right? Authentication, authorization, and then accounting. So first of all, when you connect to my network or when you come to advanced assessment, we need to authenticate you, right? So that means you provide us with something, you provide a system with your username and your password, and then the system checks that information that you provided with what it has on the server. And then if you're part of advanced assessment, then it grants you access to advanced assessment. But authorization says, yes, you are authenticated to be part of advanced assessment, but which resources are you authorized to have access to, right? And then authorization, we control that using what we've spoken about, the role-based access control, the mandatory access control, the discretionary access control. So yes, you have been authenticated to advanced assessment resources. You have the correct username, you have the correct password, then you have access to advanced assessment resources. But authorization says which resources are you authorized to have access to, right? So you have access to resources. If we're using role-based access control, then you only have access to the resources that you need to carry out your everyday job, right? And then number 3, third part will be, the third A is accounting, meaning that whatever you do to our computers, if you delete an application, if you delete something on the computer, if you uninstall an application on my computer, audit trails, we must be able to tell who deleted what in our computer because of what? The audit trail. Without authentication and then authorization, it becomes difficult for us to really audit what exactly is happening in our computers. Does that part make sense? The AAA. The first part we said is authorization. You are granted access to our network, right? Authorized to access our network. And then number 2, second A is authentication. What is it that you are authorized to access? Number 3, accounting. Whatever is happening on our network, we need to be able to tell, okay, who did what in our network, who deleted what, who made some changes on our network. So that's what access audit is all about. Okay, number 5, list 2 possible factors which could impact on this response time achieved by the LAN. Which 2 impacts, possible impacts, list 2 possible factors which could impact on the response time achieved by the LAN. So we talk about the speed of the LAN. What is it that can affect the speed of the LAN? What do you think can affect the speed of the LAN? Kamo?
Sam.
Yeah.
I can say it's a throughput and a latency, Sam.
Yes, so throughput basically is just the speed of a network, right? Like how fast the network is, the speed, that's the throughput. So it really doesn't really answer my my question, right? So my question is, list 2 possible factors which could impact on the response time or the speed of the network. So I'm looking for something that can affect the speed of the network, because the throughput is just the speed of the network.
So what about the latency, Sam?
The
latency.
Latency is the delay. What's the delay? For example, if you send a message to someone else, right? The latency is whereby just the delay that happens during that communication. That's the latency. That's the delay. Latency is just the delay.
Okay.
So the answer that I'm looking for this one, right? We can say if you choose the wrong medium, right? The medium, for example, we have the Ethernet cables. The Ethernet cables, we said they use electrical signals to transmit data from one computer to another computer. And the speed of those usually is like 45 MB per second, and some is less than that. And then the fastest medium now is the fiber. Fiber is faster than all of those. So we have copper, we have copper, Ethernet falls under copper, and then we have wireless, we have fiber, we have coax. So if you choose the wrong medium type, it can affect the speed of your network. So we're looking at the medium can affect. And then also the switch, the type of switch that you're using, it can affect the speed of your network. For example, your Ethernet cable. Okay, let me show you an Ethernet cable, what exactly, how it looks like. So you can see down here, I have my Ethernet cable here. This is the Ethernet cable, right? So this type of cable, it uses electrical signals to transmit data from one computer to another computer. And then it has slower speeds when we compare it to fiber. I think I have a fiber optic cable somewhere here. Okay, I don't have fiber close to me. So, but this is the Ethernet cable. So the type of medium that you're using can affect the speed of your entire network. And then number two, the type of switch that we are using. Some switches only operate on a maybe, let's say, or only support, let's say 100 MB per second. Even though your Ethernet computer, your Ethernet cable is 1000 MB per second. If the switch is only 100 MB per second, then the switch will slow down your entire network. It will drop the speed of an Ethernet cable to the speed that it can run on. Meaning that if your Ethernet cable is capable of 1000 MB per second, and then your switch is only capable of 100 MB per second, then even though your Ethernet cable is transmitting at 1000 MB per second, it will end up dropping the speed to 100 because that's what the switch can transmit on. That's the speed the switch can handle. So a switch can affect that, and then a router can also affect that, and then other network components part of the network part, or the network design. The network design can also affect your network. If you designed it wrong, it can affect the speed of your network. So those are things that you can talk about when answering that question. All right, that was question number
5.
Number 5. Okay,
Oh,
we've
Melusi, can you please repeat on the speed, because I heard you speaking about the type of speed when you said 100.
so the speed we're talking about the Ethernet cable, right? We said your Ethernet cable might be supporting or capable of running 1000 MB per second, which is 1 GB per second or 1 GB per second, right? And then now your switch only can carry maybe let's say 100 MB. So now the switch, again, the type of switch that you've bought, it can slow down your entire network. So that means all of the devices in your network will be only running on 100 MB per second. So that can slow down your entire network. Right. So the type of medium that you choose can affect your network speed. The type of devices that you choose can affect your network speed. So you can talk about the switches, you can talk about the routers. So the routers come in with different capabilities. So if you're using the old routers, it might not support some of the new technologies or new new protocols. So the type of router that we're using also can affect the speed of your network. All right, moving along to question number 1 from question number 5. We have number 1 says, explain the reason for using diagnostic tools in relation to a LAN. So in your LAN, in your LAN network, why will you need a diagnostic tool? So that's question number 6 on my side here. It says number 1. Question number 6, explain the reason for using diagnostic tools in relation to ELAN. Come on, you want to try that one?
You will say. Ah.
Can I try?
Yep.
I think we're using diagnostic tools to a LAN network in order to troubleshoot the network problems.
Right. So basically, you want to identify any problems, any potential performance problems in your network, right? So we use the diagnostic tools to find out, okay, what exactly is causing your network to fail, or what might cause your network to fail in future. So that's the main reason for diagnostic tools. They are there to identify potential performance problems within the network. Remember, we spoke about the what you call the baseline, right? We can also use the baseline to refer to it and say, okay, is there any changes? Did our network change from how it used to perform in the beginning? Right. Number 7 says list 3 possible. Kidibone?
Melissa, what about the benchmark? Is it the same with the baseline, or because when
The
you
benchmark, well, the benchmark is the standard.
oh, okay,
The
so
standard that has been put in place or stipulated by many organizations to say, okay, your network is supposed to at least be running on this speed. So it's a benchline, like it's a baseline for everyone. It's a benchmark for everyone.
So we wouldn't like on question number 6, we wouldn't add we're just going to add baseline, not benchline.
No,
So
no benchmark. Yeah.
Oh, okay, thanks.
So yeah, we're saying now diagnostic tools are just there to identify potential problems, potential performance problems within a LAN, right? And then let me see if I can find any diagnostic tools. Okay, no, let me just quickly go through this so we can finish this, and then I will show you the diagnostic tools. Okay, question number 7. List 3 possible sources of support requests that may be received from your users. List 3 possible sources of support requests that may be received from your users. So where can your users get support from? Support, we're talking about if they are facing any technical query errors, who can they go to? Where can they get the support?
Can I say the technical team?
We're starting with the local, the technical team, right? In-house technicians.
Yes.
And then we can talk about the supplier staff. Let's say you bought a switch from Cisco. So the guys, let's say we bought a switch from one of the supplier who communicates directly with Cisco. So that supplier would have been trained by Cisco in terms of like how the Cisco device works, and then if it faces any problem, how to fix that specific problem. So the supplier staff, they can also be able to help us with troubleshooting or fixing any problems. What else? What else did you guys write there? So we say the supplier staff, the in-house technical staff, the local expertise, third-party professionals. What else did you write on your side, guys? Because I believe most of you have written this already, right?
Melissa, we only wrote the ones that we think we know, but then we never wrote the rest. So yeah.
All right. Question number 8. List 2 types of viruses often encountered. These two. Okay, no topic.
Can I say malware?
It's malware, right? But there are so many under malware, right? Like there are so many viruses that fall under. Okay, we have a malware and then we have a virus. Like, okay, let me start with there's a virus, right? Called a Trojan Wars. Do we all know what a Trojan Wars is? So a Trojan Wars is a malware or a software that, let's say when you're downloading it, you are thinking that the software is there to help you out, maybe solve certain problems in your computer. For example, I'm sure you have seen a software that always says, that pops up and say, you need to, your PC is slow, you need to upgrade or download this software so that it can increase your computer speed. You've ever seen a software like that? You have never seen a pop-up like that? That states that your PC is running slow. You need to download a certain software so that
Yes,
can up your. We have, right? So that software,
yes.
we call it, that malware, we call it a Trojan Wars. Most of them, it's just a malware, right? So we call them the Trojan Wars. The reason why we call it a Trojan Wars is because it appears as if it's a tool that is there to help you out. But in the end, it's just a malware that is either maybe it's a spyware collecting information about you or collecting information about the keystrokes. Let's say when you're typing a password, it collects those keystrokes. You're typing a K, it collects that information. You're typing an E, it collects that information. So that's a Trojan Wars. It appears as if like it's a tool that is there to help you out, while it is a malware, right? So
Yes.
that's another virus. And then we have like soft other ones called the spoofing tools, right? Spoofing, they're just there to collect information about you, right? They're spoofing, they're collecting information about you. And then we have a worm. A worm is self-replicate. Nontomeko? Your hand is up. Your mic is on mute.
Oh, so we need to name the different viruses.
Yeah, I just need the two types of viruses. Yeah.
Oh, okay. So I said bots and bugs. Would that be correct?
What is a bot? Let's start there. Do you know what is a bot? I think those that joined Adrian's class yesterday, is it yesterday or day before yesterday? You kind of touched on the botnet, right? So a bot is just a computer that is part of a group of computers that have been affected by malware. So they are controlled by someone else remotely. So it's a bot. It's like a robot or something, right? So it's a computer that is part of a group of computers that has been affected by malware. For example, the Trojan Wars is a malware that it can be a malware that that gives or that grants access to someone else to your computer. So once you install that, you are kind of like granting access to a remote user so that they can have access to your computer. And then your computer now becomes part of a body, part of a group of computers that have been affected by malware. They are all working together, maybe to achieve one task that the owner sends out to all these computers. Does that part make sense what a bot is, Kidboni?
Oh, yes, Melusi, I just want to add, is it okay if we write all the viruses that Adrian was telling us about, like shell viruses, retroviruses, and and multipetite, because of those are some of the viruses he mentioned yesterday. So is it okay if we write like shell viruses, multipetite, retroviruses, or yeah?
Yes, it's okay. So I just need all of the types of viruses. So you listed all of the viruses, right? That may be encountered by any organization.
Okay, thanks.
All right. And then question number 9. Explain what could be done to avoid infection of the system by any or all of the viruses mentioned above. How can we prevent the virus affecting our machines? Zimbili. So how can we prevent, Mobile, how can we prevent computers from being affected by these viruses?
I would say to install antivirus software.
Install antivirus software, okay. Kidiboni, what's your answer?
Mine, I never wrote anything, but my answers, I saved them on my phone, so I can't go back to my answers. So I'll just say that my answers are saved on my gallery. So if I switch off the Teams, then I can't go back. So yeah.
All right. The other one, okay, you guys said an antivirus, right? That can protect against that. And also, other thing that can protect us is educating our users. Just educate these users. So educate the users, then most of them, they will not fall into these traps.
Yeah. So that I think, can I add?
Yeah.
So they should stop going to shady websites, I think.
Yeah.
And
then also,
use a malware scanner.
Yep.
Yeah.
A malware scanner that can scan everything, right?
Yeah.
And then also, if we educate them, tell them not to maybe click the links, every link that they receive via emails, that can also protect them from different viruses. Right. All right. Let me do this. I want to show you something. Let me see if I can pull up that information.
So
yeah.
So what about using strong passwords?
I won't call it like it can't protect us from the malware. Will it? I don't think so. Strong passwords is just like protect us from being hacked by people like by malicious users, right? So I would say it will protect us from malware.
All right. Okay. Thank you.
The other thing that it can protect us from malware is the controls, the access controls that we spoke about, the guest, the administrator. So what we always advise people is that most of the administrators, right? So we tell them not to grant full permission to users when it comes to their computers. So just grant them access to their computer. They just have guest account access so that they won't be installing, let's say, softwares that are not really secure on their machines. So that can also protect us from our computers from being affected by different viruses. So don't grant full access to users. Just give them the permission, the guest account users, so that they can only do their job role or their everyday work without having more permissions, like installing different applications and things like that. Yeah, Kidbon?
Yes. What about email filtering, Melis?
What about?
Email filtering.
Email filtering, again, we have tools that filter emails. That's very important, especially if like it looks for signatures. Email filtering, it looks for signatures, right? For example, if there is anything that sounds like or looks like there is a link that looks like maybe coming from an outside organization, email filter will pick that up and then tell you, okay, this link is coming from outside an outside organization. It's not trusted. If like maybe let's say you trust that email, then you can go ahead. But it kind of like picks up emails that we can't trust and then shows the user that this email is not trusted. So email filtering is one of the tools that we can use to protect us from malwares. All right,
Okay.
so here's a Virustotal. This is the tool. Is this a free tool that you can use to before you install any application or before you install any software in your machine? You can test it using this Virustotal. So this Virustotal is a tool that uses different antivirus softwares. For example, let me just show you what I mean by that. So if I choose a file, let's say there's a file that I'm not sure of if it's safe to install or to run, then I upload it. I say open, and then there's the file confirm upload. So now my machine is testing this to see if the virus, if the file is not corrupted or it doesn't contain any malware. So you can see down here, instead of using Adware or only one antivirus engine, I'm using how many? I'm using a lot of them. I'm using a lot of antivirus engines here. That's the ones that are testing my system. You can see here I have Acronym Static, I have Avast, I have Dr. Web. So you can see all of these, they have detected that there is no virus or this is a safe document. I can use this document because it is safe. So if you don't have an antivirus in your computer, then you can, and then you're not sure if the software or the tool that you want to install in your computer, it is a malware or what, then you can download that and then test it using the Virustotal. The good part of this is that it is not only it's not only tested by one engine, right? By one antivirus engine. It is tested by different engines. That's the advantage of this one. And also, if let me say go back, because I'm done. If I want to test maybe a site, I'm not sure about a site if it's safe or not. Let me copy advanced assessment site. Let me copy that. If it's a site that you want to visit, but you're not sure if it's safe or not, you can copy that site before you even go to it, or you can type it the URL there. And then all of the antivirus engines will test that. You can see it says it's clean, it's clean, it's clean. And then they pick up that as a clean website or a clean site. So if you want details, you can get the details there. Information about the links, community, what the community is saying about this, you can get that information there. So this one comes in handy when you don't have an antivirus. So someone else, let me see something. Let me check if I can. On search, if you are searching like for an IP address that you don't trust, you're not sure what an IP address is. So yes, okay, let me go back. So this is the tool that you can use to test different applications in your computer before you even install them. All right, let me come back, explain what could be done to avoid infection. We have gone through that. Okay, I think I'm done for today. See you guys at 12. So just take 15 minutes break and then you join at 12. On my side, I'm done. Any questions before I close?
I have a question, Melissa.
Yeah.
When is the due date for module 5 and 6?
Module 5 is next week, Monday.
Okay.
Module 6, don't worry about it. We're doing it next week.
Okay, thank you.
Okay. Good morning.
Oh, Lucy, you said that, okay, can you repeat on the Virustotal? You're saying that if you don't have an antivirus on your computer, you can install the Virustotal.
Yeah, you don't install the Virustotal. What you do is
You don't, you download, I mean, sorry, you download. You can
don't download it. Just type
okay.
virustotal.com. That's it. You see where it is? You just type in virustotal.com. And then let's say now there is an application that I'm not sure if it's safe for me to use. Let me do this. Where are my downloads? My downloads. You see, I have this MPSA. Okay, I'll check it on. I'll take it from downloads. Let me go back here, and then I wanna check a file. Choose a file from your computer. Let's say maybe where did I see that? Was it under downloads? So you can see, maybe let's say I just finished downloading this application, right? I want to install it in my computer, but before I install it, I want to scan it first, right? Just to find out if it has any virus or not. So I just click on that and then open. So you can see different antivirus engines are testing that, are checking if it is a virus. So you can see most of them, they're saying no virus detected on that, because that's a Microsoft application. Let me look for one that is not from Microsoft. The one that I think is Doji. Where can I get one that is Doji? Okay, we're gonna do it that one tomorrow. For now, on my side, I'm done. Just take 15 minutes break and then join at 12.
Okay, thanks.
Okay, bye.
Bye.